Next question that we have is differentiate the following function f of x equals to the cube root of x plus square root of x. So again, we have a chain rule here. First, we'll take the derivative of the cube root function, and then we keep this argument inside without touching it, and then we multiply by the argument or the function that is under this cube root. So we have f prime of x equals to. So let's actually rewrite that as a power rule. So we have, or the power. So we have x plus square root of x to the power of 1 over 3. So f prime of x is, we bring down this 1 over 3, and we have x plus square root of x without doing anything to the power of 1 over 3 minus 1, which is negative 2 over 3. So let me remove that and put it negative 2 over 3. Now times the inside, which is the derivative of x is 1 plus the derivative of square root of x is 1 over 2 square root of x. So now we just simplified. We get 1 plus 1 over 2 square root of x over 3 cubic root of x plus square root of 3 square root of x all squared. Now I want to get rid of this denominator here, so I will multiply by 2 square root of x top and bottom. So in this case, I would have 2 square root of x plus 1 over 2 times 3 is 6, cube root of x plus square root of x squared times square root of x. So now I can technically write this one a bit on this, like between them, or I can actually leave it as is, and this is the end of the problem. Now, an important thing is that you cannot cancel this square root of x in the numerator and denominator because this term doesn't have a square root in it. So you cannot just kind of cancel these two. You need to factor out square root of x first, which you don't have in the second term, and then you can cancel. But right now you cannot. Now, next example, use implicit differentiation to find the second derivative of y for the equation 2x squared plus y squared equals to 8 and simplify your answer if possible. Okay, so we have 2x squared plus y squared equals to 8. So as you can see, we cannot technically isolate y. We can isolate y on the one side of the equation and put everything to the other side. However, we will have two branches, and that might be a problem to take the derivative. So we will use the implicit differentiation here. We have 4x plus 2y times y prime equals to 0, right? So when we take the derivative of both sides with respect to x, this is what we end up with. Now we'll solve for y prime, and we have y prime equals to negative 4 over x over 2y, which is negative 2x over y. So we have y prime equals to negative 2x over y. Now we can take the second derivative of this function. We would have on the left side, we have second derivative. On the right side, we have a quotient rule. So we will have negative 2 times y minus negative 2x times y prime over y squared. So now we will simplify it. We have negative 2y plus 2xy prime divided by y squared. But now we do know what y prime is, so we will substitute this y prime with negative 2x over y. So I have negative 2y plus 2x times 2x over y with a negative sign. So I'll put that negative here. And then divided by y squared. So this guy right here, that's my y prime. with the minus, of course. So now let's simplify that. We will multiply everything by y, and we would have negative, let me factor out negative actually. So I have negative 2y squared plus 2x, oh actually it's 4x squared, and we just cancel the y and we divide by y cubed. Okay, now we can factor out 2 from the numerator, and we have negative 2 times y squared plus 2x squared over y cubed. Now let's look at the very beginning. The function that is given to us is 2x squared plus y squared equals to 8. So when we have this y squared plus 2x squared, this is exactly what our function is, and that is equal to 8. So we can substitute this expression with 8. Let me show you again. This is the expression that we will be substituting with 8. So you end up with negative 2 times 8 over y cubed, which is negative 16 over y cubed. And this is the end of your problem. This is y double prime is equal to negative 16 over y cubed. Now, next problem is find the equation of the tangent line to the curve at the given point. X squared plus 4xy plus y squared equals to 13 at 2, 1. Okay, so remember that the equation of any line is y equals to mx plus b, and also we have y minus y1 equals to m times x minus x1. Now, if we convert that into calculus, we would have y minus f of a equals to f prime of a times x minus a, right? And now if we solve for y, we would have f of a plus f prime of a times x minus a. So a is given to us, and f of a is also given to us. So the only thing that we need to find is this f prime of a. So now we have x squared plus 4xy plus y squared equals to 13. As you can see, we cannot do explicit differentiation, so we'll need to do implicit differentiation, and then we will evaluate at a equals to 2, or x equals to 2, sorry. So what we have here is 2x plus 4y plus 4xy prime plus 2y times y prime equals to 0. Now we solve for y prime. We have 4xy prime plus 2y prime equals to negative 2x minus 4y. Now y prime equals to negative 2x minus 4y divided by 4x plus 2y. And now you can just plug in the values of x to be equal to 2 and y to be equal to 1. Or you can technically even substitute all the values here, and once you found your once you did your implicit differentiation, just substitute x and y everywhere you see, and that would be easier to solve for y prime. Since I already solved for y prime, I will just plug in the values. I have negative 2 times 2 minus 4 times 1 over 4 times 2 plus 2 times 1, and I get negative 4 minus 4 over 8 plus 2. So I have negative 8 over 10, which is negative 4 over 5. So this is my derivative. So now I will substitute all the values that I know. I have y equals to f of a is 1 plus f prime of a is negative 4 over 5 times x minus a is 2. So now I just simplify it. I get 1 minus 4 over 5x plus 8 over 5, and I have negative 4 over 5x plus 13 over 5, and this is the equation of a tangent line through a point 2, 1. And that is it. Now this one will be a little bit longer problem because it has 6 parts. So the first thing is a particle moves according to the law of motion. S of t equals to 0.01 t to the fourth power minus 0.04 t cubed, where t is greater than or equal to 0, is measured in seconds, and the function itself, S of t, is in feet. So the position is in feet and t is in seconds. So first question is find the velocity of a particle at time t, and what is the velocity of a particle after 1 second. So to find the velocity, we first need to find the derivative of our position function, right? So we have 0.01 t to the fourth minus 0.04 t cubed. Now to find the velocity, we need to find the derivative of this position function. So velocity is s prime of t, which is 0.01 times 4 times t cubed minus 0.04 times 3 t squared. So I have 0.04 t cubed minus 0.12 t squared. Now the velocity after 1 second is v of 1, which is 0.04 times 1 cubed minus 0.12 times 1 squared, which is 0.04 minus 0.12 is negative 0.08 feet per second. So please don't forget about the units. Now, part B is when is the particle at rest? The particle is at rest when its velocity is equal to 0. So let's calculate that. We have 0.04 t cubed minus 0.12 t squared equal to 0. So t squared times 0.04 t minus 0.12 equals to 0. So we have either t equals to 0 or 0.04 t minus 0.12 equals to 0. So t is equal to 0.12 over 0.04, which is 3 seconds. So particle is at rest at 0 seconds and at 3 seconds. Now, part 3 is when is the particle moving forward? So what we have here essentially is 0, t equals to 0 and t equals to 3. So we want to find, since we said that t should be greater than or equal to 0, we are not counting this portion of the graph because this is back in time, essentially. So we need to check what is the sign of the velocity function between t being 0 and 3 seconds and after t is greater than 3 seconds. So we need to pick some values. So let's say I pick a value of 2 and the value of, let's say, 3. Sorry, 4. So v of 2 is equal to 0.04 times 2 cubed minus 0.12 times 2 squared is equal to negative 0.16 feet per second. Okay, so it's going to be negative here. And now v of 4 is equal to 0.04 times 2 to the fourth, sorry, 4 to the third power minus 0.12 times 4 to the second power. That is going to be equal to 0.64 feet per second. So as you can see, this is going to be positive. So the conclusion is particle is moving forward after 3 seconds on, right? So from 0 to 3 seconds, particle is moving backward. Next portion is find the acceleration of a particle at time t and after 1 second. So part D is, again, velocity function is 0.04 t cubed minus 0.12 t squared. To find the acceleration, we need to take the derivative of the velocity function. So this is going to be our acceleration, which is 0.04 times 3t squared minus 0.12 times 2t, which is 0.12t squared minus 0.24t. And this is the acceleration function. Now, acceleration after 1 second is going to be 0.12 times 1 squared minus 0.24 times 1 is 0.12 minus 0.24 is negative 0.12 feet squared per second. All right, so that is it for the part D. Now part E, graph the position, velocity, and acceleration function on one graph for the first 5 seconds. You will technically see that it goes to infinity after 4 seconds, but let's do for the first 4 seconds so that we have at least some kind of grid. Okay, so let me do kind of a small graph here. So what I have here is negative 0.25, negative 0.5. Here I have 0.25 and 0.5. I don't think that we need any more. So this is 0, this is 1, this is 2, 3, 4, 5, and we don't actually need more. So let me make it a bit smaller. Okay, so for position function, s of t, we had 0.01 t to the fourth minus 0.04 t cubed. So let's see where it is equal to 0 so that we can find the points on the x-axis where we have our position function kind of crossing that line. So s of t equal to 0, we have 0.01 times t to the fourth minus 0.04 t cubed equal to 0. T cubed times 0.01 t minus 0.04 equal to 0. So t equal to 0 or t equal to 0.04 over 0.01, which is 4 seconds. So I can put a point at 0 and at 4. Now I see that this is a polynomial, so most likely I have some kind of movement like this or like this. So I need to see what happens at the vertex. How do I find the vertex? So if I have something like this, right, then I see that at some point I have this velocity equal to 0, right? So I need to find where the velocity equals to 0 so that I can find my vertex. If I have a parabola that goes kind of this way, right, I have a minimum which also shows that I have a vertex at where the velocity is equal to 0. So let's go back and see where our velocity was equal to 0. So velocity was equal to 0 when at t equals to 0 and at t equals to 3 seconds. So at 3 seconds, I am expecting to have either the maximum or the minimum. So I need to check that. And So S of 3 is equal to 0.01 times 3 to the fourth minus 0.04 times 3 cubed, which is negative 0.27. So I have a point at 3 seconds and negative 0.27, so approximately somewhere here. So it's 3 comma negative 0.27. So I have a function something like this, like that. And also don't forget that at 0, we also have the velocity is equal to 0. So my function is not kind of going directly to this point. It kind of carefully slides down from this 0 tangent line to the next tangent line right here. So it's gonna go like this. All right, so this is my position function, S of t. Now, next one, we will be looking at the velocity function. Remember, we already did some calculations. So the velocity at 1 second is negative 0.08. So let's just use it. So at 1 second, I have negative 0.08, so probably somewhere here. And then I also know that velocity is equal to 0 at 0 seconds and 3 seconds. So I would expect to have a point 0, 0 here and 0, sorry, 3 comma 0 right here as well. So now, since I have at 1 second, I have it under the x-axis, so I'm expecting some kind of this this type of behavior. So I want to find where that kind of vertex is, right? Again, if I find the vertex, this would be the point where the derivative is equal to 0. The slope of this tangent line is a vertical line, right? So the derivative should be equal to 0. So I want to see where acceleration equals to 0. So I have a of t equals to 0. So 0.12 t squared minus 0.24 t equal to 0. T is equal to 0, or 0.12 t minus 0.24 equal to 0. And I have t equals to 0.24 over 0.12, which is 2 seconds. So I am expecting at t equals to 2 to have a vertex for my velocity. So now I need to calculate what is the velocity at 2 seconds. And we actually did that before, right? So that was this point, negative 0.16. So let me write that, negative 0.16. So at 2 seconds, I have negative 0.16 is probably somewhere, I guess, here. So this is going to be my vertex. So let me now kind of graph carefully this, something like this. Actually, maybe something like this. So this is my velocity function, right? Next function would be the acceleration function. And as you can see, the acceleration function is a parabola. We know the acceleration at 1 second, it's 0.12. And as you can see, acceleration at 0 should be also 0 because we have t in both terms. So I would have a point here, 0, 0. Then I have also 1 comma negative 12, which is probably somewhere here. In the middle. So we just calculated when acceleration is equal to 0 at 0 and at 2 seconds. So let me mark that on my graph. I have acceleration here is 0 and at 0, 0. Now I want to find the vertex. How do I find the vertex of a parabola? Remember, the vertex happens at negative b over 2a, comma f of this negative b over 2a. So this is my B, this is my A, right? So the vertex would be at negative negative 0.24 divided by 2 times 0.12, which is positive 0.24 times, divided by 0.24, it's 1 seconds. So we need to calculate A of 1, which we actually did, and that's going to be negative 0.12. So vertex happens at 1 comma negative 0.12. And let's show that. Oh, we actually have it. So this is where we have our vertex. So now what I'm gonna do is I will just connect these points, and well, I can technically even continue that to the 5 seconds, right? So something like this. And this is my acceleration function. So these are all three graphs that we have. Now, the last question that is asked is, when is the particle speeding up or slowing down? So let's look at the graph, and let me zoom in. Remember that the particle is speeding up when velocity and acceleration function have the same sign, and slowing down when velocity and acceleration function have different signs. So let's look at this carefully. So from 0 to 2 seconds, both the acceleration and velocity are negative, right? So let me mark that. So here, so from 0 to 2 seconds, acceleration and velocity both have negative sign, right? They're both under the x-axis. So this is where we speed up, because the signs are the same here. Now, after 2 seconds and between 2 and 3 seconds, we see that the acceleration, the velocity, yes, the acceleration function is positive, velocity function is negative. So from 2 to 3 seconds right here, acceleration is positive, velocity is negative, so their signs are different. So we have particle is slowing down here. And then after that, we see that both after 3 seconds, both acceleration and velocity are both positive. So the particle is again speeds up. It's speeding up, right? Okay, so let's write that. From 0 to 2 seconds and from 3 seconds on, the particle is speeding up, and from 2 to 3 seconds, it is slowing down. And when t is between 2 seconds and 3 seconds, particle is slows down. And that is it for this problem.